Hey, thanks for joining me. Today we're going to talk about multiplying and dividing integers. Now, sounds hard, but notice we're doing two things because we think you're so smart you can handle this. And it's not that hard. Here's the rules. Remember, for adding and subtracting integers, there was this whole list of the rules that we had to follow. We had to follow them in steps, and there was like 4 rules we had to remember. But in multiplying and dividing, the rules are the same. So for multiplication and division, multiplying or dividing two integers, the rule is this: same signs, positive, different signs, negative. That's it. Let me show you. Okay, so we've got 2 times 3. 2 times 3, you know, is 6, and it's always been 6, and so what's the point? But notice that 2 is positive, and 3 is positive. The signs are the same, so the answer is positive, which is not a huge revelation. But how about 2 times negative 3? You would expect the answer to be somewhat different because we're multiplying by a negative. 2 times 3 is 6. One sign is positive, one sign is negative. They're different, and so the answer is negative 6. That's how the rules work. Piece of cake. Negative 2 times 3. Well, 2 times 3 is 6. One sign is negative, one sign is positive. Different signs, so the answer is negative 6. So notice we get negative 6 whether it's negative 3 times positive 2 or negative 2 times positive 3. Same answer. Okay, now here's the tricky one. Negative 2 times negative 3. Now, we're used to thinking, well, there's a few negatives, it's negative, and if it's a lot of negatives, it's really negative. But that's not the way this works. Negative 2 times negative 3, 2 times 3 is 6, and there's a negative and a second negative. The two negatives are the same signs, are the same, so the answer is positive. So 2 times 3, positive 2 times positive 3 is 6, and negative 2 times negative 3 is also 6. And that's a little bit weird. And that leads us to our next rule, which is not if the signs are the same or different. That's the rule for two integers. For many integers, if there are an odd number of signs, oops, I said it backwards, but you know what I mean. If there are an odd number of signs, then negative. Even number of signs. Oh, I said that wrong. I'm still saying it wrong. Let me say it again. Odd number of negative signs. So odd number of negatives. Then the answer is negative. If there's an even number of negatives, then the answer is positive. Now, let's think about that. When there was 0 negatives, then the answer is positive, even number. When there was one negative, then the answer was negative. It's odd number. 1 is odd. Work both ways. When there's 2 negatives, then the answer is even. What about when there's 3 negatives? That's a completely bad way to write that. 3 negative signs. Okay, so what do we do there? Well, think about this. Negative 2 times negative 5. The rule is the signs are the same. The answer is positive. 2 times 5 is 10. That's that first bit. And then times negative 4. Well, this time the rule is signs are different. 10 times negative 4 is negative 40. But we didn't have to do it one piece at a time. We could just recognize that there's 3 negatives, and therefore that odd one, right? 2 negatives are going to cancel each other out, make a positive, but that odd one is going to make it always go back to negative. So if it's an odd number of negatives, it's negative. If it's an even number of negatives, it's positive when you're multiplying or dividing. This works for division also. Okay, let's do it one more time. So 10 times negative 3 times 4. It's so much easier if we can choose the order we go in. So it'd be a lot easier to do 3 times 4, which is 12. It's negative 12 because negative 3 times positive 4. And then 10 times negative 12 is negative 120. It's the easiest way to do it. You can do it any order you want. But notice there was a positive, a negative, and a positive. There was an odd number of negatives, just one, and that makes the whole thing negative. Okay, now so far we've been applying these rules to multiplication. We're going to get to division in a minute, but I want to show that that last rule is most helpful when it comes to exponents. Because we've done exponents, remember exponents just mean multiply this number by itself a bunch of times, right? So negative 3 squared means negative 3 times negative 3. Well, there's two of them, two negatives. Negative times a negative is positive, so positive 9. But we knew there was two of them because it was 2 right there. So that was an even number. And it gave us a positive result. Okay, well, what about negative 3 cubed? Well, that's negative 3 times negative 3 times negative 3. That's what the little exponent 3 means. And negative 3 times negative 3 is positive 9 times negative 3 is negative 27. So there was an odd exponent. It gave us a negative answer, right? Because there's an odd number of negative numbers being multiplied together. And negative 3 to the 4th power, well, let's apply the rule. This is an even exponent, which means the answer is going to be positive. But what is 3 times 3 times 3 times 3? Well, 3 times 3 is 9, and the other 3 times 3 is 9, and 9 times 9 is 81. You can do it on your calculator if you want to. But once you understand the rules, you can do these a little bit faster. But if you need to, write it out, negative 3 times negative 3 times negative 3 times negative 3, and do a little piece at a time, you're welcome to do it that way as well. If you find yourself making mistakes, go back and do it the long way so that you can kind of cement those patterns into your mind, the way these work. And then as you become more and more convinced that they're going to work every time, then you can start taking shortcuts. Well, let's do some shortcuts on the last one. The last one has an odd exponent, 5. There's 5 negative 3's being multiplied together, which means that the answer is going to be negative. Now, how are we going to do that? So that's 3 times 3 times 3 times 3 times 3. I'm going to cheat. Remember, we had 3 times 3 times 3 times 3 is 3 to the 4th power is 81. If I multiply one more 3, I'll get 3 to the 5th power. 24, so 243, 81 times 3 is 243, but remember, because it's an odd exponent, there's an odd number of negatives being multiplied together. The answer is negative 243, and there we have it. Okay, that is exponents applied to negative numbers. I'll point this out, and I don't know if you're going to see this, but there's a difference between negative 3 squared and negative 3 squared. Just want to point this out. This may not come up, but if the parenthesis is around the negative, that means that you're going to do the negative number squared. So negative 3 times negative 3, which we already said is positive 9. But if there's no parenthesis there, then what it's saying is, and this is what you actually do, you do this first, 3 squared, which is 9, and then you put the negative on afterward, because the negative kind of acts like a minus sign instead. So if it was minus 3 squared, you would do the 3 squared first, and then you would minus the answer. So two different looks, with parentheses, without parentheses, can change what your result is. So be careful with that. But I don't know if that's going to come up a lot. I think we'll probably just keep parentheses around for most of ours. Okay. Let's do some division, and I didn't have a good division sign, so I used some words here, and that's fine because it's good to be able to translate. Okay, so 15 divided by negative 3. 15 divided by negative 3. Okay, there's a lot of ways to write that, right? We could write 15 divided by negative 3. Let's talk for a minute about those parentheses. We like to put parentheses around negative numbers because negative numbers are kind of confusing. Like, is it minus 3? Is it negative 3? So if you put the parenthesis around it, then there can be an operation sign here, adding, subtracting, multiplying, dividing, and we won't get that operation mixed up with the negative sign here. So that's just a little thing that we do, and I encourage you to practice that when you write out your problems. Okay, we could write it that way, but there's another way we could write this. We could say 15 divided by negative 3. Okay, so that's writing it as a fraction, but that actually is a little bit more comfortable for some of us because we're used to reducing fractions. It's a little bit easier to reduce the fraction 15 over 3 rather than 15 divided by 3. We could write that fraction, the exact same fraction would have the exact same meaning if we said negative 15 over 3. Okay, and that's kind of stating that the whole answer is going to be negative. And it's true because there's only one negative, right? Its signs are different and the answer is negative. Or we could write it as negative 15 on top over 3. They all mean the same thing because they all have one negative, which means the answer is going to be just one negative. And in fact, you know what it is. It's negative 5 because 15 divided by 3 is 5. So the rules apply here, and that we have to watch out because that negative could be in any position in that problem. Okay, now let's do this next one, the quotient of 12 and 14. So that means negative 12. Negative 12 divided by negative 4. Did I say 14? I meant negative 4. Okay, now let's write that as a fraction. Negative 12 over negative 4. Now here, there's no question where the negative signs go because there's one for the numerator, one for the denominator, so we can't like move things around. I suppose technically we could say negative 12 over negative 4 or negative 12 over 4. Technically we could say that, but the easiest thing to remember here is that there's two negatives, they just cancel each other out. So the answer is going to be positive because the signs are the same. There's two negatives, one on top, one on the bottom. The two numbers being divided are both negative, and so the answer is positive. And of course the answer is positive. Oh, I said it wrong. I was thinking 3, I promise. Positive 3. Okay, signs are the same, or we have an even number of negatives being multiplied or divided. The answer is positive. If the signs are different, the answer is negative. Let's do one last problem, and this is where that parenthesis is really going to come in handy. We're going to evaluate x, y, and then we're going to evaluate x over y. So this is a multiplication problem. Xy means x times y, and x over y means x divided by y. So we have a multiplication division problem using the values x equals negative 18 and y equals negative 12. And the only reason I'm going to do this problem is so that you can see the value of when we replace variables with their values with numbers. It's really a good idea to put parentheses. So x becomes negative 18, and I put a parenthesis around it just in case there's something confusing going on. That would make it unclear what we're doing if there wasn't a parenthesis there. And you can see how it would be unclear if I didn't put a parenthesis around the y value. Y is negative 2, so parenthesis around negative 2. Now we can clearly see that yes, we are multiplying here because I put two numbers with parentheses next to each other. That means multiplication. If the parentheses weren't there, it would look like I was doing a subtraction problem or an addition problem. And that's not what we meant to say. So that's going to be real important. It's not always necessary to put parentheses, but it's usually a good rule of thumb just to put them in, just to make sure, and then you can evaluate and see if they are really needed. Well, negative 18 times negative 2, they're both negative. Two negatives equal a positive, and 18 times 2 is 36. Okay, what about the quotient? Again, this time I don't really need the parentheses. Why don't I need parentheses here? I hope you're saying to yourself, because that fraction bar acts as a parenthesis. It's kind of separating the number on top, the negative 18, from the number on the bottom, negative 2, so I don't really need parentheses because of that fraction bar kind of doing all the work of the parenthesis for me. But it's okay, just in case I put them in there, and then I said, oh, I don't really need them, so I took them out. Negative 18 divided by negative 2, of course, is going to be positive, and 18 divided by 2 is 9. There you have it. Thank you very much. This appears to be a really easy lesson, but it doesn't mean you shouldn't practice. So make sure you're practicing and getting them right, checking your answers in the back of the book. Thank you very much for watching.